Okay, everyone, so we're on our second to last chapter, which will be more integration. So we're going to start with integration of exponential functions. So here are the rules before we look at some examples. If they ask you to integrate e to the x, it'll simply be e to the x plus c. Since we have an indefinite integral, meaning I'm not integrating between any two numbers, we have to add the c. So don't forget. If you want to integrate e to the power of ax plus b, instead of multiplying by a, which we did when we found the derivative, we're going to divide by a. We always do it backwards when we're integrating. So the integral of that would be 1 over a times e to the ax plus b plus c. So we can look at some examples now. First, I will integrate e to the power of 3x. So 3 here would be my a, and there is no b. So we have to divide by the 3, leave the exponent alone, and add your c at the end. What about e to the negative 2x? It's the same process, but we're dividing by negative 2, which is the same thing as multiplying by 1/2. E, leave the exponent alone, add your c at the end. E to the 5x minus 4, divide by 5, leave your exponent alone, and add a c. So I don't have an example necessarily, but I just wanted to show you that if you got an example that looked like this, or this, you want to either distribute if you're multiplying before you integrate. So here I would have e to the 2x plus e to the x that I would be integrating. And here I would have e to the x over e to the x plus e to the x over 1. So I would integrate 1 plus e to the x. I just made these up, but I guess I'll go ahead and finish them. So since we're adding, we can just integrate each term separately. And that's what makes it easier than dealing with this multiplication. So here, 1/2 e to the 2x plus, if I'm dividing by 1, it's not going to change anything, e to the x, and then I have to add my c. Here, when we integrate 1, it becomes an x. E to the x doesn't change, and you add your c. So those were indefinite integrals because we weren't integrating between any two numbers. So here, let's try one that's a definite integral. Evaluate the integral between 1 and 2 for 9e to the 3x minus 1. So remember that when we're integrating, we're actually finding the area under a curve. So for this, it would be the area under the curve between the x values of 1 and 2. So my exponent is a 3, I have to divide by 3. But this time we have a coefficient in front. Okay, so 1/3 of 9, I get 3e to the 3x minus 1. Now we don't add c when it's a definite integral. we have it between 1 and 2. So first you plug in 2. So 6 minus 1, it's 3e to the 5th. Then we subtract and then plug in the second number, 3e squared. So this can be simplified further. Take out a 3e squared from both terms, and we get e cubed minus 1. They could also give you the graph. Of a curve. And this curve is y equals x squared plus e to the negative 2x. And they want the area under the curve between the x coordinates 1 and 2. So to integrate an x, remember that we add 1 to the exponent and then divide. So this, the integral of x squared, is 1/3 x cubed. The integral of e to the negative 2x, so we divide by negative 2, so it's subtracting 1/2 e to the negative 2x between 1 and 2. One third times 2 cubed minus 1/2 e to the negative 2 times 2. And then I'll subtract and plug in 1. And let's simplify. 1/3 times 8 is 8/3 minus 1/2 e to the negative 4th. 1/3 times 1 is just 1/3. And 1/2 e to the negative 2nd. So I kept them separate so I don't forget to distribute my negative here. So 8/3 minus 1/3 is 7/3. Minus 1/2 e to the negative 4th. Then this negative times a negative makes this positive 1/2 e to the negative 2nd. So they wanted the area. This doesn't tell me a whole lot. So you would just plug it into your calculator, depending on what the question wants from you. And the area here is approximately 2.39 square units. So that was integration if we have e. Now we're going to talk about integration of natural logarithms. So if you see something that looks like 1 over ax plus b, this is when it will integrate to become a natural logarithm. The rule is, if I have 1 over x, it integrates to ln of x plus c. So I use the absolute value of x because you can't take the natural logarithm of a negative number. If you're interested in researching more about this, go ahead. So if I had 1 over ax plus b, you're still going to divide by the leading coefficient and then take the natural logarithm of the absolute value of the whole denominator and add a c. Let's look at some examples so this will make a little bit more sense. If we want to integrate 2 over x, anytime there's a constant, you can pass it through an integral or a derivative. So I could say that this is equal to 2 times the integral of 1 over x dx. So that means it's 2 times the natural log of the absolute value of x plus c. If they want you to integrate 4 over 2x plus 1, you will still pull the 4 out. That's my constant. So the 4 stays in front. We're going to divide by 2, or multiply by 1/2, and multiply that by the natural logarithm of 2x plus 1, and add a c at the end, and just simplify to become 2 times the natural logarithm of the absolute value of 2x plus 1 plus c. And then if I have 6 over 2 minus 3x, you want to be careful here because this is written in reverse order. Not ax plus b, but b plus ax. So remove the constant. We have to divide by -3. Multiply that by the natural logarithm of 2 minus 3x and add your c. So this becomes -2 natural logarithm of 2 minus 3x absolute value plus c. So for our final example, we'll look at a definite integral involving the natural log. So let's integrate between 2 and 3 for the problem we just did. Okay, we already found the integral, so let's not do that over again. We're going to use this, but remember when it's between two x's, you leave the c out. So we have -2 ln of 2 minus 3x absolute value between 2 and 3. Okay, so 2 minus 9 gives you -7. Then I subtract -2, so plus 2 ln of the absolute value of 2 minus 6, or -4. So I'm going to switch the order now because it's actually subtraction, not addition, and that will affect how we use our logarithm rules. So we can get rid of the absolute values. 2 ln 4 minus 2 ln 7. Pull out a 2. And then remember, when we're subtracting logarithms, you're actually going to divide them. So we get 2 times the natural logarithm of 4 over 7. So let me know if you need any help with your homework. Remember, you can put problems into the Google Doc that you want to go over that day so I can get them ready, or just show up, or send me a remind message, whatever. I hope you're all doing well still, and hopefully see you soon.